We're in the workshop now. Going to start on the electric modifications. We're going to see how these tick, how they work. I've rigged up the power supply. I've got a car partly taken apart. I've already taken the screws off the bottom of this, so I'm going to tip it over and you can see what's inside. I've already taken the screws out, so I'll take that off. There we go. Microprocessor controlled board of some sorts. Power goes in here. You've got the negative there, then it's bridged across to the other track. This is the out on for the tracks. As you can see, they're bridged. I'm going to be changing that because we want to do analog and digital. You can see there's a smoothing capacitor there by the looks of it that's coming out there that feeds the accessory sockets. Carrera do a range of accessories that you can plug into these sockets. I'm going to be using it for the charging. So I'm going to be measuring the voltage here to see how it is. I know the standard digital power supply. Let me show it there. They are 14.8 volts, just under 15 volts at 3.5 amps. That's a standard digital supply. So we'll see how the board controls that voltage, how it rectifies it down. I'll turn it over. I'll plug in the power supply. We'll measure the voltage on the rails. .74 volts. So obviously the processor, the microprocessor on the boards are controlling the power to make it go down from the standard 14.8 to 13.74. That's pretty standard because a normal scale electric or analog power supply is around about the 13 volt mark. Yeah, put a car body on, see what's going on with them. I've already took the body off this Corvette. Obviously, with an analog car, this would be running now. I'll actually demonstrate that in a second. Obviously, because this is digital, it won't. It'll only run when I put it runs. This whole system was copied from model railways. I think Hornby actually innovated it with the 01 system back in the 80s. For some reason 01 died a death and digital didn't come back into model railways until in the 90s. And then obviously once it took off big time. Now I think more or less everyone uses digital model railways. This system is a similar system. Obviously the voltage is on the rails. Every time you control something, like pressing the button or pushing the throttle down, the processor inside here is going to be sending, I would think it's probably a PWM, a pulse wave modulation signal down the rails that tells this chip what to do with the motor and the lights. Obviously when the car's stationary you can switch the lights on and off using the digital button. You run that. If I take my foot off the throttle you'll see the brake lights come on as well. That's the brake lights. Obviously the chip on the car is controlling that. The chip on the car has taken the 13 volts, not letting it through to the motor, but there's a main chip on there. I would think that's some sort of triac. That's going to be, there'll be a processor on there as well. They'll be talking to each other, and the power to the motor will be as required on the throttle. It's a very clever system. If I take that off and put a standard analogue car in, you'll see what's going to happen. This analogue car is going to think that the throttle's at maximum. I'm going to go loopy. I'm going to go off, as though it's maximum throttle, but I won't hold it. There we go. Now if that was a normal analogue, that would now be at full throttle. That's the difference between analog and digital. Analog, there's no voltage on the rails until you push your hand on the controller. This acts as a variable resistor that controls the power to the track. Obviously it's incremental, so it'll go from like 0 volts all the way up to 13 volts, depending on where you got your hand on the throttle. It's a very simple system, built obviously I think the first ever slot cars go back to the 1930s, I think, when motors were invented. But it was made big in toys, obviously, in the 50s and 60s. I'm going to put this back on, so what I'm going to want to find out, I want to find out what the voltage on the lights are. I suspect it'll be the same as the rail voltage. Rail voltage is 13 volts. If you can see that on there, I'll just check on the camera, see if you can actually see that voltage on the meter. I think you can probably make it up. Just going to measure the voltage on the pins on the lights. There we go, look, 13.6 volts. So it is rail voltage. So basically switching the lights on and off, it's literally just a switch on the board that's controlling that. It's taking the rail voltage and putting it straight to the LEDs. The reason I want to know that is for future modifications. An analogue car only has volts there when the voltage is obviously up. I think they mostly use LEDs, but I know the original analogue cars, they used tiny little bulbs, and the faster you went, the brighter the bulbs were. So obviously, because you're putting more voltage to the track, I'm going to switch this off and turn it around, and we'll see what the voltages are on the inside. I don't need a controller, so I'll disconnect that. Going to find out what the voltage to the accessory rails are. So we're using that for charging. So I assume there's no voltage there at the minute, and we will check. Still plugged in. No, there's no voltage there. Oh no, the meter's come out, so. No, there's no voltage. There's no voltage to the accessory sockets when there's no power. We'll switch it on. We've got them the wrong way around. There we go, so we've got the voltage back to the track again. Right, let's see what it is on the accessory sockets. Rail voltage again, so 13.75 volts there. It's probably a little bit of drop off from the capacitor. As you can see in this board, you've got the main board here. This red and black wires are the main feeds for the rails. A little speaker there for the beeping. These red and the yellow and blue wires are the feeds for the infrared pickups on the track for the picking up when the cars go by. And the digital signal. Obviously that only works with the digital cars. There's the black. We'll ignore the black because the negative is going to be the same on analog or digital. What's important is the red. What we've got to do to have an analog track, we've got to separate the rails. I've actually made up a circuit which is going to control that, which I will go get. Alright, this is the circuit. I will put in the video, I will actually put it up as a picture for a few minutes. What it is a 3-pole double throw switch in the middle. Switching it one way, we'll have it digital, switching it one way, the other analog. You study the circuit when I put the picture up and you'll see how it works. On the analog side, on the analog side of the switch it separates the rails. On the digital side of the switch it will combine the rails. That's basically how it will work. They'll also switch the power over between analog and digital, as it's a 3-pole switch. It's fairly simple, fairly basic electronics. Good thing about this unit, it's very easy to separate. The actual power unit, it literally just clips in. Once you've undone the screws, this power unit clips in. By doing that, what I'm going to have, this set here, the power section, the bit that controls, that's all going to be separate to the actual main track. I'm going to be using waterproof connectors to combine it all. Nice and easy. Because obviously this main power section can't live outside. It'd be more or less impossible to waterproof that. There's only 1, 2, 3, 4, 5. There's only 6 cables there to combine. Also going to be adding a 12 volt lighting system. 12 volt system to power various accessories on the layout, like scenic accessories and lighting. So all I need is an 8-pole connector to do the whole lot. Nice and simple. It's a little bit odd that they've used the same colour wires. You'd think when this was manufactured, you'd think they'd use different colour wires for the infrared sensors to distinguish between the two. But I suppose it's not really designed to become a part, so it's not really a problem. Repair is going to be quite simple. It's a simple PCB replacement should it ever go wrong. I suspect Carrera don't actually sell the parts separately because you're not supposed to fix them yourself. I'm going to keep a spare power base just in case one does go wrong. Let's see. The microprocessor side of electronics are the most likely things to fail at some point. But it's a fairly simple system. To sum up, derived from model railway technology. The rail changes are the same. They have a small PCB inside with an infrared receiver and a electromagnetic solenoid. So it's basically a model railway point motor in one unit. Pressing the button on the digital control triggers the car to send out an infrared signal. The car passes over the receiver and it switches the lane. Very simple technology. Same with his. Obviously an infrared signal's coming out, it passes over the track and knows the car's gone past the start and finish line. I'm going to take some photographs of this, make some notes before I start cutting wires. But it's all pretty simple. Right, I stripped it all down. I've added, I removed the accessory section bit that plugs in for the Carrera accessories, because that's not needed. I've added decent size jumper cables to the rails, two on each, one for joining to the as a power jumper for the rest of the rails, and the other one is the main feed to the actual control units. So it's all separated now, so that'll be both good for analog and digital with that circuit that I mentioned. I've added jumper cables onto the infrared receiver LEDs, infrared receivers, so they're longer, different colour cables, but I wrote it all down so I could keep an eye on the colours. What I've got to do now, I've got to get some sealant, carefully put it around these LEDs and put it through. Obviously, because it's an outdoor track, they've got to seal the top end of the LEDs to stop the water running through the hole where the LED is. So that will cause a problem with corrosion. So what I'm going to do, I'm going to put a small amount of sealant on this bit of paper here, and use a cocktail stick to carefully apply the sealant around it without getting too much on, because it only needs a small amount, just enough to give it a seal. Just going to use this pointy end of the stick. Just need to get some just around the outside of the edge of this. Don't need to put too much on, so otherwise it contaminate the LED. I will, once it's in, I'm going to tape it down like it was before, and then I'll clean the top end with some white spirit to clean off the excess. This is an adhesive sealant, so that will also glue it in place as well. I'll put some duct tape on the top to hold it down, and I'll flip it over and clean off the excess with some white spirit, because the sealant is a spirit based sealant, or mineral spirits if you're in the USA. It's called. Turn it over and clean off the excess. There's nothing really come through anyways, but I'll give it a wipe just in case. In the UK that's called white spirit. So I always use spirit based sealants. They're a lot better than the acrylic versions. That's it, that's ready for this particular piece. Will be ready for installation and carrying on the wiring. I cut up the plastic part that went over here, just enough for the cover off the PCB section. I'll be cutting these tabs off, probably keep them ones for screwing this down. On this control unit, I'm going to be adding, obviously for analog control, I'm probably going to be using the Scalextrics Sport for that, because the controllers, to keep the controllers separate. Also got to add charging bases for the wireless controllers, and also the switch for controlling analog to digital. Other than that, it's going good. That's another small section done. Next section is going to be waterproofing the lane changes. With that, going to be using some epoxy resin and sealant, just like we did with this to do the LEDs again, infrared receivers.